We have found 500 planets in orbit around other stars. Most of these exoplanets are very large gas giants, many much larger than Jupiter, and are detected by measuring small dips in brightness as the planet moves across the disk of the host star. While these measurements can be made from ground-based telescopes, we can make more precise measurements from space. And in 2009, NASA launched the Kepler Space Telescope with the mission of finding smaller planets, planets more like the Earth. The Kepler mission is designed to look at only one region of the sky for its entire lifetime. Its goal? To find terrestrial planets, defined as those 1/2 to twice the size of the Earth, and especially those in the habitable zone of their stars where liquid water and possibly life might exist. Many question why, in our search for life elsewhere in the cosmos, we limit our search to Earth-sized planets within this so-called habitable zone. Surely we can't predict what may be possible in a galaxy with over 100 billion stars. Why would we limit ourselves so severely? For example, one could imagine that life could arise in sulfuric acid oceans with extremely high pressures, or perhaps in a dry, cold, rocky world, or perhaps even in one of the huge gas giants already discovered. So why are we so concerned about this habitable zone and finding planets the size of the Earth? While it is entirely reasonable to contemplate all possibilities, searching for all of them isn't practical. When embarking on a search of such magnitude, it makes sense to start our journey with what we know is possible. We know that life can emerge and thrive in an environment and under conditions similar to ours. We know this because we are here. The Earth is teeming with life. Since the search for life elsewhere in our galaxy is so daunting, so magnificent in scope, what limited resources we do manage to bring to bear on this search should be carefully designed and executed to ensure maximum return for our efforts. We are seeking an answer to one of the most important and profound questions humanity has ever asked. Are we alone? Kepler is designed specifically to help answer this question. It stares at only one area of the sky and will do so for the entire mission. It is recording the light from over 100,000 stars similar to our Sun for over 4 years in the constellations of Cygnus and Lyra, an area rich in stars. On January 10, 2011, after gathering and analyzing over 8 months of data transmitted from the spacecraft, the Kepler science team announced the discovery of the first rocky, Earth-sized world, Kepler-10b. The good news is that this world is roughly the size of the Earth. It is 1.4 times that of our home. The bad news is Kepler-10b does not lie within the coveted habitable zone. The orbit of this planet around its star is 20 times closer than Mercury is to the Sun. It would be extremely unlikely to find life here. The temperatures on this world reach 1800 Kelvin. The surface, pulled and torn by the tidal forces of the star, are fractured and sculpted by molten rock as it orbits the star once every 20 hours. There is almost no chance that life could ever emerge here. The discovery of Kepler-10b is a significant milestone in our search for terrestrial planets and for life elsewhere in the galaxy. This find is a harbinger of the discoveries to come. If Kepler can find such a small world so close to its parent star, then finding these planets around other stars looks promising. The number of terrestrial planets ultimately located by Kepler will be very eye-opening. If it finds many, then the chances that life is common in the cosmos becomes more likely. If it finds very few, then humanity may face a lonely future.